Scientists estimate that the plastic in the ocean will outweigh the fish in the ocean by 2050. Entrepreneurs around the world are racing to find more environmentally friendly substitutes. From flip-flops made from algae, to plates made from pineapple scraps. This is how people are replacing plastic to cut down on worldwide waste. Americans eat about 6 billion avocados every year. That's 6 billion pits that, it turns out, can be made into something called bioplastic.
A company has developed a process to transform avocado pits into plastic. Bioplastics like these could help reduce pollution because they break down faster and use less fossil fuels. But how they're made and disposed of determines if they really are a cleaner alternative. We visited Biofase in Monterrey, Mexico, to see how it all works. This factory produces ready-to-eat guacamole and salsa. They tried composting the avocado scraps, but it didn't work. So now they sell their seeds to Biofase. Bioplastics are what we call products that are mostly made of biological substances instead of petroleum. The process starts with avocado seeds that have been washed at the supplying factory.
Nuestro siguiente paso es que la semilla del aguacate entra a nuestro proceso patentado mediante el que nosotros generamos el bioplástico con el que fabricamos todos nuestros productos.
As the seed is going through the machine, it's turned into a bioplastic resin that's ready to withstand a lot of heat. What comes out the other end is a malleable sheet that can be molded and cut into different shapes.
Esta lámina va a pasar en el futuro a un proceso que se llama termoformado, donde esta lámina le vamos a dar una forma, le vamos a recortar y vamos a poder generar productos como contenedores de alimentos, platos, tapas de café, en fin, la imaginación es el límite.
Studies have shown that bioplastics are an improvement over traditional plastics. It takes less fossil fuels to produce them, they contain fewer toxic chemicals, and they decompose faster. The technology to make these products has improved over the past few years and has grown to a nearly $20 billion industry. That's about the same size as the rapidly growing plant-based meat industry. Biofase is part of that trend. Today, it has 3 locations across Mexico. But there are issues. Bioplastics require special industrial facilities to properly compost, and they can contaminate the regular recycling stream. They're also more expensive than regular plastic, which is made from readily available petroleum.
There are 2 reasons. Because first of all, crude oil is quite cheap right now. And secondly, the production capacity for bioplastics is much lower, while for fossil-based plastic, it's much bigger. So they have an economy of scale in terms of production.
Biofase produces about 130 tons of bioplastics each month. That's equivalent to the conventional plastic waste produced by 13,000 Americans. It's a modest output for now, but Biofase products are shipped across Mexico, the UK, and other countries in Europe. And the company recently expanded to Australia.
In India, one brand is creating tableware out of the waste that is usually burned for fuel.
This is called bagasse. It's what's left over from processing sugarcane. About a third of the plant becomes waste as it's refined into sugar. During the harvesting season, India produces enough of this sweet-smelling pulp to make these giant dunes, around 100 million metric tons every year.
हमको तो अच्छी लगती है, हम उसके आदी हो गए हैं, तो हमको बहुत अच्छी लगती है.
Now, one company is transforming it into plates, bowls, and trays that are designed to break down in a backyard compost heap.
Plastic stays forever, so it's not going to go anywhere. In our case, if you throw it, then it'll disintegrate in 3 months max.
But does this kind of plant-based alternative make a difference if it still ends up in a landfill? We went to Uttar Pradesh, India, to see how Chuck is making biodegradable tableware from worldwide waste. Polystyrene was discovered in 1839.
And is 10 to 20 times lighter than the fluffiest meringue.
It wasn't used for plates and packaging until more than a century later. as fast food chains went global. But recycling has never caught up. That's apparent across India, where an amount of plastic equivalent to the weight of the Taj Mahal ends up in streets and waterways every 2 weeks. The idea behind Chuck is to replace some of that plastic with biodegradable sugarcane waste. India is the world's second largest producer of sugar, making more than 25 million metric tons in 2020. And that means mountains of bagasse.
Eventually we realized that we have sugarcane pulp, and that can be molded into different products which can actually be used as placement for these styrofoam products. Chuck was really good because, of course, it was about disposable. You can chuck it. It was also good with chuck, which is taste in Hindi.
Ved set up shop near sugar plantations and mills to keep costs and the carbon footprint low. Around 100 truckloads of bagasse arrive at the Chuck factory every day during peak harvest season. It can take 2 hours to unload each truck.
If the material dries out, the fiber loses strength, so we have to keep it in wet piles.
Workers then remove a layer of the tiniest fibers before washing and pressure cooking it.
Same concept as you cook dal in your home, the same way you cook bagasse. You use a certain alkaline product to be able to remove the stickies. If you think of a sugary product, it's a little sticky.
The alkaline solution helps make it moldable. Workers wash the sludge again to remove any residual chemicals. Then they distribute it into different machines and molds that press it into shape, squeezing out all the water. Other companies bleach their products, but Chuck decided against it.
We were told in the market, Indians don't like to eat in brown, it has to be white. But I said, no, if we are true to our basic idea that we want to be more ecologically sustainable, then we have to stay with lesser and lesser chemicals.
Chuck also sources a starch-based compostable packaging for its products, instead of virgin plastic.
We, of course, realize that our whole ecosystem, DNA, world revolves around the idea of leaving the earth cleaner. So if that is the case and we package in plastic, then we've defeated the purpose.
Workers like Shilwadi check the finished products for quality before counting and packaging.
इसमें high breathing है, low breathing है, cracking है, moisture है, fiber missing है, तो इस लाइट के सामने दिखाई देता है.
The Chuck factory can crank out 1 million individual items in a day. And that's only half of what Ved says is possible with the current setup.
We are still figuring out a lot of the technology.
By the time they reach consumers, Chuck products end up being about 20% more expensive than items made from plastic. Chuck's meal tray costs 10 rupees or 13 cents, while a plastic tray costs around 8 rupees or 10 cents. Another reason Chuck costs more? Ved insists on paying his staff a living wage.
I think we are very proud of having lots of local people. More than that, we are proud of having 50% women, and they're amazing.
Some women like Shilwadi can make up to 10,000 rupees a month, or $131. That's nearly double the minimum wage in the state of Uttar Pradesh.
इसमें भी मिल जाता है, खर्चा चल जाता है अपना. 2 बच्चे हैं, पढ़ाई लिखाई में लग जाता है.
So are products made from bagasse better for the environment? Probably. Chuck recommends leaving its products for 90 to 180 days in a backyard composting bin that maintains moisture and good oxygen flow. But they can still harm the environment if they end up in a landfill, where they won't decompose as fast. Plastic, on the other hand, never really goes away. It just keeps breaking down into smaller and smaller particles.
A company in Colombia is making dishware out of pineapples to cut back on plastic.
These plates are made from the tops of pineapples that are shredded, mixed with some recycled paper, and turned into sheets that are left out to dry under the sun. A machine presses the sheets into form. And if these disposable plates end up in a place with soil and water, tiny seeds inside will blossom in a few days.
El producto fue diseñado no solamente para que se degradara o se biodegradara o se compostara, sino además quisimos ir más allá porque es que el producto te genera vida.
On a busy day, workers at LifePack can churn out 10,000 eco-friendly plates.
Hemos usado residuos que antiguamente los estaban botando y eso lo estamos transformando. Entonces, esa es la ventaja, esa es la diferencia que nosotros estamos haciendo.
In addition to plates, the company also makes sandwich containers and coffee cup sleeves that contain seeds from edible plants like cilantro, amaranth, and strawberry. LifePack caps its own carbon footprint by working with local suppliers.
Para hacer nuestros cartones y papeles nosotros no talamos árboles y eso es un factor esencial porque, digamos, dejamos de talar 16 árboles por cada tonelada de producto hecho por nosotros.
It sources pineapple waste from a nearby processing plant. The plant's owners charge nothing for the pineapple crowns. They're happy that someone is willing to turn their waste into a resource.
Nosotros lo que hemos buscado es cómo hacer el tema de la economía circular y la corona pues nos parece que no puede quedar en mejores manos que en ellos que han hecho un trabajo tan bonito. Pues para nosotros lo que ellos hacen es muy importante.
Husband and wife team Claudia Barona and Andres Benavides founded LifePack 12 years ago in the city of Cali. The couple has won several small business awards, and they even appeared on the Colombian version of Shark Tank.
Porque cada vez que nosotros veíamos que habían reuniones en casas, en apartamentos, en fincas, en asados, en parques, siempre veíamos la contaminación tan grande que había con estos otros productos tradicionales, que son de plástico o de espuma.
Colombia, like nearly every country in the world, is trying to reduce plastic waste. In 2017, the country introduced a tax on single-use plastics that increases each year. And in some cities, informal pickers are now paid as municipal workers. But getting consumers to buy these products isn't easy.
Cuando nosotros iniciamos, que fue hace más o menos unos 10 años, la gente nos decía que estábamos locos. Porque aquí en Colombia, casualmente, la gente no era muy amigable con el medio ambiente. Todo el mundo utilizaba lo más barato.
The LifePack plates retail at about $2.50 per dozen. That's more than double the price of plastic plates from a big box store. Despite their higher price point, LifePack has been able to capitalize on growing demand for sustainable packaging, which has increased by 40% since the company started. Its plates are now sold in 3 large supermarket chains domestically. The company also handles dozens of orders through its website each week, with a handful of customers in the US.
En un solo turno de trabajo podríamos hacer quizás unos entre 6,000 y 12,000 platos. De hecho, ahorita hay más demanda que oferta, entonces estamos sobrevendidos. Eso significa que la respuesta en el cliente es positiva y que el producto tiene un mercado.
LifePack's next challenge is to modernize its equipment so it can boost production. Andres and Claudia also plan to franchise the business and expand into new countries to help more people cut back on plastic, one plate at a time.
We make over 1 billion flip-flops a year, and they're piling up on beaches and in the ocean.
Most are made from plastic foam, which takes decades or centuries to break down naturally. But these researchers, growing green, slimy algae, may just change that. But can this new kind of foam really replace regular flip-flops? We visited their lab to find out. Steve Mayfield runs the lab that makes the flip-flops. He's studied algae for 35 years, and he's still excited to talk about it.
They are the most efficient photosynthetic organisms on the planet.
And they're easy to grow and harvest in man-made ponds, using less land than plants. The process for turning algae into flip-flops is surprisingly simple. The shoe consists of a footbed made from flexible foam, an outsole made of a more rigid foam, and a cotton strap. To make the foam pieces, the researchers use an industrial machine to mix together compounds created from algae oil.
This is the same machine you'd see if you went into any one of the shoe manufacturers in the world. We want to make sure that the research and the work we do here is relevant to the real world, to the commercial world.
The machine pours the mixture into molds. The team then applies heat, and the foam expands into the shape of a shoe. They wait about 10 minutes for the foam to cure, then peel the pieces out and assemble the finished product.
You put the strap through here and then put the back 2 parts here, you glue that on, and then this entire thing glues, and that's it. That's all the shoe is. So the manufacturing of these things is also really straightforward.
The sandal is 100% biodegradable, It takes 3 to 6 months to break down in a compost pile, or if it ends up in the ocean, it would take about a year. That's much faster than the average flip-flop made from plastic. And replacing traditional plastic flip-flops with algae-based ones would also reduce the demand for fossil fuels.
Petroleum itself is biodegradable. They become not biodegradable when they go through a refinery and then a chemical company converts them to a plastic that is not biodegradable. So all we're doing is, instead of digging algae oil out of the ground, we're growing algae oil in ponds.
That's why, for years, researchers around the world tried to turn algae into a low-cost, low-emission biofuel. And for the last 15 years, private investors and the US government poured billions of dollars into this research. But despite those efforts, no one has yet figured out how to make algae biofuel cheaper than fossil fuels.
We're always going to be 5 years away from making algae biofuels economically viable. Maybe we should tackle one of the other problems that the world has that are a little easier to achieve economically.
They shifted their focus to biopolymers, or plastic alternatives made from plants. They sell at a higher price than fuel.
Number one, they're about 10 times more expensive than fuel, so the economics works out better. But number two, plastic and ocean plastic pollution is an enormous problem, and we need to address that.
One company in upstate New York maintains that mushrooms hold the answer to our plastic problem.
It looks like a giant marshmallow, but it's actually a mushroom. This lab grows an eco-friendly replacement to styrofoam, that light but bulky material taking up a third of the space in all landfills. But can this company grow it fast enough to make a global impact? We visited Ecovative's headquarters in Green Island, New York, to find out. The magic is in mycelium, the living root structures of mushrooms.
Our entire philosophy is actually based around this idea that nature provides. Mycelium is a great solution to both the plastics waste problem we face as well as animal agriculture.
I'm taking the mushroom mycelium, and then I'm just going to section this petri dish.
All Ecovative products start with these natural building blocks.
We have about 100 different strains in-house, and we will analyze those for the different material properties that they have.
What do you think about the wall thickness on this? It's pretty thin.
The company's best-selling product is called Mycocomposite. It has similar properties to styrofoam, but it's completely biodegradable.
We've worked with a variety of companies, some of them huge companies like Dell Computers, where they've used our earth-friendly packaging to ship servers. We've worked also with small New York startup brands like Keep Candles.
Manufacturers design molds using large, recyclable plastic sheets. Heat makes the sheets pliable, so they can be shaped around any product. They start with wood chips, corn husks, or hemp that would otherwise be thrown out by local farms. Then sprinkle in some fungal spores and add water. Pack the mixture into the molds, and the mycelium starts to grow, feeding on the shredded agricultural waste. Just over a week later, the form-fitted mold is ready to ship.
So this jar, and it fits really nice in there.
The final material is a little bit heavier than styrofoam, but velvety soft to the touch. This packaging breaks down in just 30 days. Conventional styrofoam never really goes away. It can stay in the environment for up to 5 centuries, and less than 1% is ever recycled. Eben Bayer and Gavin McIntyre founded Ecovative Design in 2007 and debuted their Mycocomposite packaging in 2011. Since then, a growing number of cities and states have banned the use of styrofoam. But the United States does not have countrywide restrictions, and the average person still uses 75 foam coffee cups per year, adding up to 25 billion. In 2020, Ecovative produced over 6 million pounds of its foam alternative, but that's just 0.5% of the cups Americans consumed. And it's currently building farms with the capacity to produce 1 million pounds of mycelium per year. The company recently announced it's raised a total of $100 million in capital. Ecovative design is a long way from displacing plastics and factory farming. But according to Eben, his company is harnessing the potential of the living world.
My background and journey has been around figuring out how we can reimagine working with nature and using nature to create better solutions for everyday products we have to use as humans that just have less impact on the earth.
Another company is betting on algae to reduce the amount of plastic in almost any product, while also cleaning the air and water.
Too much algae can hurt natural ecosystems, and sometimes make toxins that endanger humans and animals. Can this invention rid the world of harmful algae and fight greenhouse gases? We visited 2 factories on opposite sides of the globe to find out. It's a race against time to clean harmful algae out of waterways before it dies.
It'll sink to the bottom, it'll decompose, it'll release those nutrients back into the water column, and then with sunlight and water again, you're gonna have another bloom.
Rotting algae also releases methane, a greenhouse gas over 25 times stronger than carbon dioxide. Ryan Hunt co-founded Bloom in the hope that monetizing algae will lead to cleaner waterways. But first, you have to get microscopic algae out of the water. Bloom made a machine that can do that on the spot. Engineering firm AECOM rents the harvester and has used it to clean up harmful blooms in New York and Florida. Bloom buys algae from around the world and turns it into plastic pellets at its headquarters in Mississippi. First, workers run the algae through a grinding machine.
This equipment allows us to mill the algae into a very fine powder and select the particle size that we need for our process.
Then they blend the powder with plastic. The machine creates hot strings of the mixture. A blade cuts the strings into pellets, and water passes through the system.
The pellets are cooled out of the molten state into a rigid form, and they're dropped into a super sack where we can store them and we can package them for use by our customers.
Nearly every plastic product is made from pellets. Brands can buy Bloom's algae pellets to replace traditional ones in their products.
We started with making flower pots. That's evolved into making sneakers for Adidas and a whole bunch of other products such as sports grips and traction pads.
Now, Bloom's pellets are mostly used in foam for shoes. Algae can be a good substitute for plastic because it contains lots of protein. But algae pellets can't completely replace regular ones, or the final foam wouldn't be springy enough.
Typically, we'll use anywhere from 10 to maybe as high as 30% of the algae in the final foam, just depending on that performance need.
One of Bloom's customers makes its product here in Dongguan, China. This factory produces sock liners, the foam part of a shoe that sits under your foot. It's made from 15% Bloom pellets mixed with traditional plastic ones. Technicians carefully measure out the 2 types, and then a machine mixes them together. After that, it's business as usual for the foam factory. Workers knead the pellet mixture and shape it into sheets. Then a machine heats the sheets under pressure until they expand into foam. Workers trim the foam sheets and mold them into the finished sock liner. Bloom shares data on the environmental impact of the pellets, which brands can use for marketing.
We can calculate the environmental impact on a gram per gram basis. We can tell you exactly how much water was cleaned and how much carbon was captured in that shoe.
Ryan says each pair of sock liners kept about 8 grams of carbon dioxide out of the atmosphere and cleaned about 17 liters of water. Dr. Scholl's Shoes has made more than 2 million pairs of sock liners since it started working with Bloom, which the companies say kept about 17 metric tons of CO2 from the atmosphere. That number includes carbon dioxide removed from the air by algae and emissions that were prevented by using algae in place of plastic. But at the end of the day, it's still more plastic, right? Most shoes made with Bloom are not any more recyclable than regular ones.
We are faced with a difficult challenge because the footwear materials typically are made in a way that is not conducive to directly recycling them through traditional means.
And they're usually not biodegradable. But when it comes to storing greenhouse gases inside an object, not breaking down is the whole point. If the product degraded, it would release the carbon back into the atmosphere. Experts say this type of technology can help fight climate change.
Right now, we just send CO2 into the trash heap in the sky. But if you can take any of that CO2, bind it in a stable form, use it to make money and a valuable product, you want to do that.
But even if all the world's plastic contained recycled carbon, it wouldn't make a dent in emissions.
Right now, we emit 51 billion tons of carbon dioxide every year. The worldwide volume of plastic that's made every year is about 1 billion tons, so we cannot solve climate on the back of plastic. It's just too small. Nowhere close.
So is it worth it? That depends what problem you're trying to solve. Ryan says the main benefit of Bloom's work is cleaner water. Algae has become a major issue thanks mainly to wastewater pollution from farms. Fertilizers are full of nutrients like nitrogen and phosphorus, which make algae grow faster. Runoff creates overgrown algae that removes oxygen from the water and blocks light to creatures living below. This is called a harmful algal bloom. It can kill fish, whales, and dolphins, and make seafood unsafe to eat. In some cases, blooms can release toxins and make people sick. 43 states have documented illnesses or death of humans or animals caused by freshwater blooms. And satellite images show bloom intensity on the rise in lakes on 4 continents since the 1980s. The algae bloom sources from waterways primarily comes from Lake Tai in China. But no matter how much algae you remove, blooms will keep happening if wastewater pollution continues.
The way that we ultimately address harmful algae blooms in a long-term scenario is addressing the source of nutrients from the beginning.
That means cleaning up wastewater before it reaches rivers and lakes. The company can do this by intentionally growing algae at water treatment plants to help remove nutrients that cause blooms.
Our hope is over time, as the scale increases, we will be able to intercept more pollution upstream, which will cause less algae blooms in nature.
Bloom gets about half of its algae from lakes and half from treating wastewater. But what about the environmental impact of processing the algae and shipping it back and forth across the globe?
It does take energy to get the algae into this usable form.
A consulting firm called Earthshift analyzed Bloom's processes and found that even after you factor in these costs, algae pellets are more sustainable than plastic ones.
We're avoiding the massive amount of emissions associated with drilling for oil, extracting the oil, refining it into a specific polymer or specific chemical.
Algae also requires less land, water, and energy than other bioplastic crops, like corn and soybeans. Ultimately, Bloom's long-term mission is to teach people that harmful algae can be put to good use.
Every city has a wastewater plant. Every wastewater plant has an algae problem. But no one's addressing it. No one's recognizing the value. If people knew that the green scum in the back of their pond had value, you bet people would be harvesting it.
Hi, this is Will Story from the Worldwide Waste team. We want to bring you more stories that take a look at garbage and creative ways that people deal with it. If you enjoyed this video, please like and subscribe. We also read all the comments. If you have an idea for a video you'd like to see, let us know. You just watched excerpts from some stories we've done about reducing plastic waste. Click here for the full episodes.